Alright everybody, let's do the college algebra video of the week number 7. This one is going to be about radical and rational equations. We'll do one simple example and then two more difficult examples. Radical equations are ones that have roots in them, and in general the way to start solving these is to get the root by itself. So I'm simply going to add 2 to both sides. Now that this square root is by itself, we can get rid of it by squaring both sides. The square and the square root cancel each other out, and 2 squared is 4. Now we have a very simple linear equation to solve. I'm just going to add 1 to both sides, and I'm going to divide through by 3. Now if that went a little fast for you, feel free to hit pause in the browser and stare at it for a little while. But one important thing about radical and rational equations is that we should be checking our answers at the end, because it's possible to get answers down here that don't actually work. So what I'm going to do is I'm going to take x equals 5/3, that's the possible answer that we got. I'm going to plug it into the original equation. I'll put a little question mark on the equal sign because that's what we're testing. Now 3 times 5/3, a lot of people will think of 3 as 3 over 1. The 3's will cancel, leaving just a 5 minus 1. And it's becoming clear that this is in fact going to work as a solution because the square root of 4 minus 2 does equal 0. So what that means is the one possible solution that we got is an actual solution. I'll box it up and that's our answer. Now if we plugged in x equals 5/3 and it didn't work, we would actually have the answer no solution. So that's possible with these kinds of radical and rational equations. Okay, you have much harder problems than these in your homework, so let's do one. So this is a radical equation that happens to have 2 square roots in it. When that happens, the first step is still to get one of the 2 square roots by itself. So I'm going to add the square root of x plus 2 to both sides of the equation. Now we can get rid of the square root on the 2x plus 3 by simply squaring both sides. The square root and the square cancel on the left. However, on the right, we actually have 2 terms here. This is a binomial, 2 plus this term, the square root of x plus 2 squared. We need to think of that like this, which is something that we need to distribute or FOIL out. So I'm going to do that. 2 times 2 is 4. 2 times the square root of x plus 2. Another 2 times the square root of x plus 2. And we have the square root of x plus 2 times the square root of x plus 2. I'll write that as the square root of x plus 2, the quantity squared. I'm going to continue to copy down every single piece here as we're showing our work. You'll notice that these 2 are like terms. We have 2 square roots of x plus 2 plus another 2. Those we can combine to get 4 square roots of x plus 2. And you'll notice on this last piece here, the square root and the square cancel, leaving us just with x plus 2. So you'll notice now that our process of getting one of the square roots by itself and then squaring both sides of the equation has eliminated one of the square roots, but it's still left the second one. So what we have to do is we have to do it again. We have to get this square root term by itself and then square both sides again. So I'm going to take the terms that aren't part of the square root term and I'm going to subtract them from both sides of the equation. So I'm going to subtract 4, I'm going to subtract x, and I'm going to subtract 2. That is going to leave us with just the 4 square root of x plus 2 on the right. Oh, and let's see, 2x minus 1x is just going to be 1x. And 3 minus 4 minus 2 is going to be a negative 3. Now you have some options at this point. You could divide through by a 4, but that's going to create some fractions. So what I'm going to do is I'm just going to square both sides of the equation now. And you just have to keep in mind that you do have to square the 4 and call it 16. Squaring the square root of x plus 2 just leaves you with x plus 2. And then this x minus 3 quantity squared is something you have to FOIL out again. So we're going to FOIL that thing out and get x squared. If we combine like terms, we're going to get a minus 6x and a plus 9. Okay, now what we have is a quadratic. I'm going to give us a little bit of room. I'm going to distribute the 16 on the right side. Since it's a quadratic, the rule typically is you move everything to one side of the equation. So I'm going to subtract 16x and subtract 32. And that's going to leave us with x squared minus 22x minus 23. Okay, that is a quadratic equation, and we can always use the quadratic formula. We could complete the square, or if we're lucky, we could factor this thing and save us some time. We won't always be able to factor, but in this case we can, which makes this pretty simple to solve. We have x minus 23 equals 0, so x equals 23. Or x plus 1 equals 0, which is x equals negative 1. So we have 2 possible answers for our original equation, which was way back here. 23 and negative 1. What we need to do is take the 23 and negative 1, and whether it's in your head or on paper, you need to plug those back in for x to see if this equation makes sense, if this equation is true. So just really quickly, if we plug a 23 in for x, we're going to get the square root of 49 minus the square root of 25 equals 2. And that is actually true. So this one we've checked. That is correct. How about x equals negative 1? If I plug x equals negative 1 in up here, I'm getting the square root of 1 minus the square root of 1 equals 2. That is not true. So feel free to check those answers on the side if you'd like. But if you do, you're going to find that x equals 23 is a solution, but x equals negative 1 is not a solution. So we have our answer, x equals 23. Let's do one more problem. I would like to do a rational equation. As you learned, rational expressions are expressions that basically are fractions that have variables in them. And an irrational equation is just a bunch of those strewn about with an equal sign in there somewhere. And our goal is to solve for x. So okay, first step is always going to be to factor. The only thing I can see factoring is this x squared minus 1. That's a difference of squares. And the difference of squares in this case factors into x plus 1 and x minus 1. Now we have the question of what the lowest common denominator is between all these terms in this rational equation. That denominator needs to include every factor that you see in denominators, but it shouldn't have any unnecessarily repeated terms. So it's probably not too hard to find that the least common denominator in this problem is x plus 1 times x minus 1. Now the whole point of finding this is we're actually going to take this term and we're going to multiply every single term over here by that, and that's going to clear all of our fractions. I'll show you how. I'm going to copy this down, except I'm going to leave a whole lot of space in here because I'm going to multiply every single term by this least common denominator here. And when we do that multiplication, the multiplication happens in the numerator. If it helps, you can call each of these over 1. But the whole point is that terms from the denominator are all going to cancel. Once you've made all the cancellations, the question is what is left. Okay, I don't think I lost any terms up here. Let's distribute through the parentheses. And who would have guessed what we have left is actually a quadratic, which we know how to handle. I'm going to get everything on the left side of the equation, and I'm going to combine like terms. So in this step, I combined the negative 4x and the positive 4x. Now I'm going to move everything to the left side. So I'm going to add 8 to both sides. And while there are multiple ways to solve this equation, the quadratic formula is still an option. Factoring is probably a better option. Simply isolating the x squared is probably an even better option. But I like to practice factoring, so I'm going to do that. I'm going to factor a negative 4 out of each one of these two terms. And what we're left with is a difference of squares. The negative 4 you could just cancel out if you want. But the x plus 1 term is going to give us a solution of x equals negative 1. And the x minus 1 term is going to give us a solution of x equals 1. And we need to check our solutions. So let's look at x equals negative 1 first. Go back to the original equation up here. And this is what I'm looking for. If you plug in x equals negative 1 into this denominator here or this denominator here, you get undefined terms. So we can't say that this is actually a solution. So we're going to cross that one out. If you plug in x equals 1 into x up here in the original equation, you get the same problem. So we can't say that that's a solution either. So I'm going to cross that one out too, but those were our only two possible solutions. So our answer to this problem is there is no solution. Oh well, maybe next time, and maybe in the next video. I'll see you then.